Okay, I am getting ready to start the unit on probability for MGF 1106, and I'd like you to get out your booklet that you purchased at Target Copy, and I want you to look on page 68. Before we do, I am sheltering in at my condo in Panama City. Great place to shelter in. I got nice views for sure. I got plenty of food. My wife is sheltering in Tallahassee. This is a very safe place as nobody is here. So whatever you're doing in your own place, remember social distancing, hand washing, that is such a key right now. So I hope you're doing it. Okay, so here we are. Again, I'm on page 68. So, the first question. Suppose we want to know the total number of ways, or the total number of ways we could get different outcomes. And here's what we're doing. We're rolling a six-sided die, and then we're tossing a coin. So one way to do this is to use a tree diagram. And basically, a tree diagram is nothing more than saying, show me, show me. So if the first thing I'm doing is I'm tossing a six-sided die, I'm either going to get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. So those are basically my outcomes for Act 1, tossing a six-sided die. Okay, now I toss a coin. Well, let's pretend I got a 1. If I tossed a coin, I would either get head or tails. If I got a 2 and I tossed a coin, I would either get head or tails. If I got a 3 and I tossed a coin, I would either get head or tails. 4, I would either get head or tails. 5, I would either get head or tails. 6, I would either get head or tails. Now here's how I count this. Here's one possibility. 1 with a head. Then 1 with a tail. 2 with a head. 2 with a tail. 3 with a head. 3 with a tail. 4 with a head, 4 with a tail, 5 with a head, 5 with a tail, 6 with a head, 6 with a tail. So basically, look what I'm doing. I'm kind of counting the total number of outcomes. Look, 1 possibility, 2 possibilities, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm sort of looking at the branches or the different pathways on my tree to determine that there are 12 ways to do this. Now, there is something called the fundamental counting principle, which is a really powerful thing because basically here's what I'm going to do. There are 2 things here that I'm doing. I'm going to roll a die and I'm going to toss a coin. How many outcomes are there when I throw the die? Well, there would be 6 outcomes. How many outcomes are there when I toss a coin? Well, head or tail, so there would be 2. 6 times 2 is 12. So much quicker to use the fundamental accounting principle than to take the time to draw this. Now, I want to look at problem number 2 because we can make use of what we just learned in problem 1. Suppose we want to know the number of ways we could get different outcomes if we draw one card from a 52 card deck and then toss a coin and then roll a die. Okay, people, the first thing is to pick a card from a 52 card deck. Do I really want to list 52 cards and then list each one of those has 2 possible outcomes with a coin and then each of those has, no. That is just way crazy, okay? Look at the fundamental counting principle. I have 3 things going on. I'm going to pull a card. Then I'm going to what? Toss a coin. Then I'm going to roll a 6-sided die. Check it out. Fundamental counting principle. If I pick a card from a 52 card deck, how many outcomes? There would be 52. If I rolled a coin, there would be 2 outcomes. If I tossed a die, there would be 6 outcomes, okay? I'm too lazy to do that by hand, so I'm going to get out my handy dandy calculator. turn it on and do what? 52 times 2 times 6 and hit enter. And it looks like what? 624. So, tree diagrams can be adorable when you're first learning what you're doing, but the fundamental counting principle rocks. That tree diagram, no way. That would have taken us forever. And why? When the fundamental counting principle says, how many ways can you do Act 1? How many ways can you do Act 2? How many ways can you do Act 3? Multiply, how many outcomes are there? Multiply them together. There's the total number of ways that can be done.